Okay, guys, so the next part is really more applications of lines. And what I want you to remember, really, really, really want you to remember is that you know the line formula. You know y equals mx plus b. And most times that is going to get you to where you need to go. Okay. Um, Always go back to that or to a table or logic. Don't think you have to memorize everything. You do not. You can think through a lot of this stuff. So it says write equations for the horizontal and vertical lines passing through the point 2, 0. This one trips people up a lot. And the reason why is because they think they're supposed to just know it, which, by the way, if you do know it, it's really easy. But if you don't, it's okay. What you do is you find the point. Okay, go ahead and graph the vertical line. Okay, we're going to go backwards from the table. So this time, what I want you to do, if you can't remember that vertical lines are X, like drop your X. Okay, if you can't remember that, what you do is you write a table and you go ahead and pull 3 lines from this thing. You don't enter it this time. Okay, you just pull them. So that's 2, 0. Okay, now go here. What's that point? 2, 1. What's that point? 2, 2. Oh, do you see it now? Check it out. What's the name of the line? X equals 2. Okay, and then for the horizontal line, you can do the same thing, although, you're on the axis. So this is y equals 0. But if you were to find points, you could find them. And it would be 2, 0. Okay, and then name another point. 1, 0. Name another point. 0, 0. Negative 1, 0. Get it? Oh, what's the name? Y equals 0. Okay, so if you could work backwards to the table, it's just as easy. Don't forget that you have strategies to get this. You don't have to memorize everything. All right, now this is finding slopes of lines parallel and perpendicular to a line given in slope intercept form. I'm getting distracted because I thought maybe I could make this a little bigger. And I can't, tiny bit. Okay, it says consider the line y equals 1/3 x. Okay, what is the slope of the line parallel and perpendicular to the side? All right, so you have a task here, and you can memorize this, and I recommend that you do. Okay, first of all, what do you know about parallel lines? Hopefully, from the project that you did at the very beginning of this unit, you realize that parallel lines have the same slope. If they didn't have the same slope, they would intersect. Okay, so the slope of the line parallel, A, is going to be 1/3 because it's always y equals mx plus b. The slope is the number that comes before x. All right, perpendicular. Okay, so perpendicular lines are at a 90-degree. And what that means is, actually, I don't think that was helpful to draw that picture. Hang on a second. Let me shrink this down so I can grab my tools. Okay, I actually don't think that was helpful. So perpendicular lines are at a 90 degrees. So I will draw an axis. Okay, I want to show you something. So we know that the line y equals x is a 45-degree angle, correct? And you know it because this is 1, 1, 2, 2. So basically, at any point we're describing an isosceles triangle, right? Look, like, check it out. Like this distance is equal to that distance. This is 45. Okay, so this is a 45-degree angle. If you want to get the perpendicular line, you would go y equals negative x. Okay, that's what this line is. These are perpendicular. Check it out. So this is 1, 1. Okay, this is 2, 2. All right, erase this so I don't have it twice. Okay, all right, so what's the slope of this line? The slope of this line is 1. Okay, if you look at this one, it's negative 1, 1, negative 2, 2, because the name of the line is y is equal to the negative opposite of x, yeah? So In this case, the slope is equal to -1. So you can see, you might be tempted to think that they're opposites, but what it is it is the negative reciprocal. So while it's easy to see that these are perpendicular, okay, if you could go play with like decimals or something, you can see that if you put in a slope of a over b, any number, like say like 2/3, okay, the slope of the line perpendicular to it, maybe I'll put perpendicular, that's the symbol for perpendicular. Oh wait, that looks like half and half, don't do that. Ooh. Okay, do you remember the symbol for perpendicular? Okay, is equal to -b over a. It's -3/2. So of course with 1 it doesn't work, but basically what you do is you flip it and make it negative. Okay, so if a slope is, say, -1/4, the slope perpendicular would be +4 because you flip it and it's over 1. Okay, so for this, in this case, flip the 1/3 and you get 3, make it negative. Okay, and that is the slope perpendicular. You do need to remember that formula. Okay, so given a slope, if you want to do it like this, I don't know if this is better. It's all the same to me. If you're given a slope a over b, okay, parallel is going to be the same, a over b. Perpendicular is going to be -b over a. Flip it, it's the negative reciprocal. Okay, so we're going to encounter that in problems coming up. So let me come down here. Come on, shrink down. There we go. All right, it says finding slopes of lines parallel and perpendicular to a line given in the form, standard form. All right, it says, what is the slope of the line parallel to this line? What is the slope of the line perpendicular? Well, to know this, you first have to know the slope, right? You can't find the slope parallel or perpendicular until you know the slope of 2x plus 3y equals -8. So what's the easiest way to do it? It depends, okay? For most people, that would be to change it to y equals mx plus b form because the slope is right here. So we could do that. You go 2x plus 3y equals -8. 2x, subtract from both sides. You get -2x minus 8. Divide everything by 3. We don't really care about the 8/3, but there's my slope. Okay, so parallel is the m is going to be -2/3. Perpendicular is going to be +3/2. Okay, it's really important. It's really important for you to know how to grab the slope. Most times people want to use this line. They're like, oh, don't we use this line? They gave us a line. No, they're just giving you the line to give you a reference point. The only reason they're giving you this line is to suck out the slope so you can find these, okay? So you always have to say, why'd they give me this? It's like dominoes. All right, so there is another way. If you'll notice, you guys, do you notice that this is A, capital A, and this is B, and it's the opposite? Some people do it that way. I've never actually memorized that, but there is a formula that the m is equal to the -b over a. And you can see why. Because it shouldn't be b over a, it's a over b. What am I talking about? I was like, why would it be that? A over b, the opposite of a over b. And the reason why is because you're always going to subtract a, the x term, and you're always going to divide by the b. Okay, so we could do it that way too. Take a look. Okay, the equations of 3 lines are given below. So they want to know whether or not they're parallel, perpendicular, or neither. I'm tired of blue. Okay, so look at line 1. We need to find the slope. I'm going to go ahead and change that to y equals mx plus b. Okay, divide everything by -4, -4, -4. We don't really care about that. Okay, and we're going to get y equals 3/2 x minus 1/2. Again, it's just me being a math person that I can't not finish the problem, but I only am interested in the slope. The only thing I care about is the slope. Okay, look at line 2. In line 2, we're going to change that to y equals mx plus b by dividing by 2. Okay, so there's the slope. Wow, they all have 3/2. They are all parallel. Now, what they're going to do is they're probably going to say like line 1 and line 2, and you would say parallel. And then they might say line 2 and line 3, and you would say parallel. Okay, but sometimes it's not going to be parallel, obviously. Maybe it would be -2/3, and you'd have to say perpendicular, or maybe it'd be 5, and you'd have to say neither. But the main idea is to be able to put it into mx plus b form and suck out the slope. Okay. Excuse me. Coffee. I hate that. I'm sorry. Writing equations of lines parallel and perpendicular to a given line through a point. I never know why this trips people up. Honestly, it's one of the most missed problems, and it makes me sad because it's not that hard. Okay, it says find the equation of the line parallel to this line and passes through the point. So here they're giving you a point, and here they're giving you a slope. That's the only reason they gave you this line. It's to give you a slope, not of this line, but of this line. All right, so then you use point slope formula, or you use y equals mx plus b. I'm going to go ahead and use point slope formula. So I'm going to go y minus -5 equals -5/8 times x minus -8. Yeah, because that's the formula. I'm using y minus y1 equals m times x minus x1. So you get y plus 5 equals -5/8 x plus 8. And then you continue. Okay, this is the lesson from yesterday. I don't need to show you. You can finish it. I can't help myself. Sorry, guys. I just have to finish it. Plus 3. All right. So you can see that it's parallel. How do you know it's parallel? Because look, we made it parallel. We put that -5/8. Okay. For B, it wants the equation perpendicular and contains this point. Okay, so, oh look, they're even giving you a graphing calculator. You can do it. I'm going to have to erase this because, I wrote it all over the place. So let me do that, and let me do the perpendicular line, green. All right, so we'll do it in green. So, okay, if you know the slope is -5/8, the perpendicular slope is going to be +8/5. Okay, we change the sign and flip it. All right, now we're going to use the formula. I'll do y equals 8/5 x plus b. And then I'll plug in the point. Okay, -5 equals 8/5 times -8 plus b. Okay, -5 equals -64/5. Did I plug that in right? I did, right? -5, and then -8, 64/5 plus b. And then I have to add 64/5. So b is equal to -5 plus 64/5. If I put that over 1, b is equal to -25/5 plus 64/5. b is equal to 64 minus 25 is 9/39. I believe. Let me see. 5 plus 9 is 14. Carry the 1 is 6. Okay. There you go. That is a weird answer. So you would get y equals 8/5 x plus 39/5. Okay. All right. The point is that none of this is new. The only thing you really are learning is to flip and to grab the slope. That is the hardest kind of like problem mathematically you'll be doing. This one is a little bit about thinking, okay, and being able to grab information from a word problem. Okay, so here we go. Abdul is putting money into a savings account. He starts with a certain amount of money, and each week he adds a certain amount of money. Okay, the cool thing about these problems, okay, well, there's limited types of math problems. There's excuse me, rate times rate, whatever, distance equals rate times time problems. Um, there are falling objects problems, there are area problems, and there are money problems like with savings, and they all kind of, you get kind of used to them after a while once you've done a bunch of them. And this one is the best way to do a problem with money is think about yourself if you were really doing this, okay? So you start with 350. Okay, that's what he puts in the bank. Okay, so that's his initial deposit. Okay, that's the word. He deposited 350, and every week he puts $70 per week. The nice thing about these is they always give you the variables, okay? Let S represent the total amount of money. So that's telling you what S is in the savings account, rather. Total amount of money in the savings accounts in dollars. We need to know that. And let W represent the number of weeks Abdul has been adding money. So W represents weeks, okay? Then use this equation to find the total amount of money in the saving accounts after 17 weeks. Oh, I was like, where did they tell us to write an equation? Here it is. Here's your verb. Write an equation relating S to W. What it's saying is write an equation about S. Okay, so you can think about this in words. Okay, his savings is going to be equal to his deposit plus his weekly deposit. Initial deposit plus his weekly deposit, okay? So S is equal to, what's his initial deposit? It's $350. Plus every week he puts in $70. And that's your equation. And then all you're asked to do is plug in the 17. I'm not really going to show you that because I know all of you can do that. That's not a tough one to do. Okay, just make sure that S is in dollars. Okay, so make sure you put dollars in your answers. Well, in Alex, you don't have to worry about it, but in other problems you would. All right, so this one is modeling a real world situation with a graph, okay? Owners of a recreation area are filling a small pond with water. So here we go. Ooh, there's a pond. Actually, I was going to draw a pool, but the truth is a pond isn't a pool. So let me draw the pond. Okay, so here you go. Recreation. Here's a small pond. Put a little fish in there. Okay. Fish. Okay, a little koi fish. There's another little koi fish. Okay, gotta have a friend. 3. There's company. Okay, there we go. All right, so we got our pond. Okay, but poor fish. If he's just filling with water, they're probably not alive. So hey, that's the future. That's the dream. All right. They're adding water at a rate of 25 liters per minute. 25 liters per minute. You can tell that's a rate, you guys. So we're going to be dealing with probably figuring out either time, usually it's a time problem. They're depositing water at a certain rate, and then they ask you how long will it take. Usually, there are 700 liters in the pond to start. Okay, good. We got some water for our little fishies. Okay. Let W represent the amount of water in the pool. W represents water in liters. And T represents the number of minutes. That's really important with time. A lot of times, especially on the SAT, you guys, they like to give you hours and ask you for minutes or vice versa. Okay, be careful. Anyway, number of minutes of water has been added. Write the equation relating W to T. Okay. So, and then it says, okay, so it says write what? An equation relating W to T, and then graph what? Your equation using the axes below. Well, you don't have any. I'm going to see what's there. Okay, So yours is going to be easier because you'll have the graph there. Okay. We're looking at 25 liters per minute, and there are 700 to begin with. So we know that the water that's in there is going to be 700 to start with, plus 25 liters per minute. And what's the other one? T. This is the same thing as W equals, or I could even say Y. Think about it this way. This is the same thing as Y. Y equals 25x plus 700. You see, this is your starting point, and this is your slope, okay? So obviously on your graph, you're going to be looking for 700. So let's say this is 100, 2, 3, 4, 5, 6, 7. And then it's going to be filling up. So it's going to be a positive slope. And it goes 25 per minute. So I'm going to assume that you might have, you know what? I can't even guess how they're going to put it. 1, 2, 3, 4, 5. So in 4 minutes, there's 25. So it would go up 25, whatever. It'd go up another one of these lines in 4 minutes. So there. I just know that because there would be 25. 4 25s equal 100, right? And each one of these is 100. It'll be easier for you guys to graph it. The important part is it doesn't go back. Do not carry this line into the negative zone. There's no such thing as negative minutes. There's no such thing. This graph only exists in a positive first quadrant. Okay. All right. I hope that was good enough. I hope it was, yeah. And it'll just go like this. Okay. All right. Interpreting the parameters of a linear function that models a real world situation. Parameters is basically like what makes sense. Okay. Ravi is a software salesman. Let Y represent his total pay in dollars. Let X represent the number of copies of history fun he sells. Okay. Suppose that X and Y are related by the equation. So they're giving you a linear equation. I hope you recognize it. It's not written in standard form or in slope-intercept form, but if I change it around, it is, and there it is. Okay, but the reason why you change it around if you need to is this is where you start. Okay, and this is X is the number of history books, and Y is his moolah. Okay, so his money, and this is the number of history books. Okay. All right, answer the questions below. Note that a change can be an increase or a decrease. For an increase, use a positive. For a decrease, use a negative number. That's important, okay? What is Ravi's total pay if he doesn't sell any copies? Well, if he doesn't sell any copies, right, he's not going to get that 110 per book. This is going to be 0, okay? So he's going to end up with 1,900. In other words, he gets 1,900 no matter what. I want a job that pays me 1,900 no matter what I do. Okay, what is the change in Ravi's total pay for each copy of History is Fun he sells? Okay, the change in pay for every single copy is $110, and that's it. So it's basically just interpreting the linear equation. All right, so here we are. We're going to be given a point, okay, and then probably asked to interpret it, okay? Suppose that the monthly cost of a long-distance phone plan in dollars is a linear function of the total calling time in minutes. When graphed, the function gives a line with a slope of 0.12. See the figure below. Okay, a lot of times these little paragraphs, especially like in the SAT, just tell you what the picture already tells you anyway. You see monthly cost, calling time, and they just kind of tell you. So sometimes you don't actually have to read it. You might only need to read it if you're confused. The monthly cost for 42 minutes is $16.71. What is the monthly cost for 49 minutes? So I assume that your graph, okay, I'm assuming your graph will have more visuals, and you'd either be able to pull out the 49 from the graph, okay, or you'd be able to write the equation of the line given, I actually don't think they're going to ask you, but you could. This could be your B. You might be able to read it, okay? So you should be able to do that unless they want you to write the equation. Let's try that. That's probably what they want you to do. That was stupid of me. Let's do that. Okay, so this is your y. Okay, so your monthly cost. Hey, did they give you not? See, if they didn't give you variables, I'm wondering if they're asking you to do it. I'm just going to put cost is equal to 0.12x. No, they didn't give us a b. So we would have to actually find a b by plugging in 42 and 16.71. I actually don't think you're going to be asked to do this hard of a problem. But you know what? You could. If you wanted, if this is what they're asking. See, sometimes I don't have access to the students part. Actually, I never have access to the student part. So I don't always know how the problems come to you. This is as much as I could pull out. I don't think you're going to have to find the B and then figure out that. I don't. I really think you're just going to be able to look at the graph and figure it out. You guys can let me know. I'd love to see this from your point of view. All right. Application, finding a coordinate given 2 points. Again, I believe you're just going to be able to find. No, you know what? Okay, I digress. I take that back. This looks like 2 points, and this looks like a point in the slope. So literally, we're solving for b because they gave us a slope. I think we are going to have to do this, you guys. They're giving you a slope. Okay, they're giving you a point. You just need to know which one is x and y. Remember, this is the y, so the money is going to be that one. That's why I put it there. And then this is the x, okay? So when you get b, 16.71 equals 0.2 times 42. So you would get your b, okay? Whatever it may be. I'm just talking while I'm doing my math, okay? And then you would get this, okay? So it's 4, well, no, it's 504, is that correct? 4, 10, 1, 5, yeah, 5.04. Okay, so it's 5.04 plus b, and then you subtract, and you're going to get, if I did my math right, you guys, 5.04, you're going to get b is equal to, I think so, 1167. Okay, and then so you get your line, and your line is y equals 0.12x plus 1167, and you can check to see if it looks like it's at 1167. Okay, then it asks you for 49 minutes, so you have to plug that in. Y equals 0.12 times 49 plus 11.67. Okay, and then this is a calculator problem for sure. Okay, make sure you use your calculator. In the same way that we did 2 points and using 2 points to find the equation of line, that's what you're going to do here. You just need to find the slope. So you have, okay, remember, calling time and monthly cost. I'm not reading this because this tells me exactly what's in the picture. I can pull out the information right here. I know I have 41, 1207, that's 1 point, 92, 18.7, that's the other point. So I can go 18.7 minus 12.07. What am I doing? I'm finding the slope. 92 minus 42. All right, and then you will get this. Use your calculator, okay? Because it's a pain in the butt to do this without a calculator. Seriously, I'm not enjoying it. I think I did this right, and then you divide it by 50, whatever. Point is, use your calculator, and then you get your slope. And then you go right back into either using the point slope formula or y equals mx plus b. And then you plug in their one that they want you to find.